A study was conducted to determine whether there were significant differences between medical students admitted through special programs, such as retention incentive and guaranteed placement programs, and medical students admitted through the regular admission criteria. It was found that the graduation rate was 92.5% for the medical students admitted through the special programs. If 12 of the students from the special programs are randomly selected, find the probability that at least 11 of them graduated. So a couple of things to point out. Let's see. First of all, it's a binomial probability, so we're going to be using that highlighted formula. Let's highlight that formula a little bit better up here. And the second thing I want to point out before we get started is that our P, the chance for success for 1, is 0.925, which means that Q is 1 minus that, or 0.075. Also, N is 12. Okay, so the first one, if 12 of the students are randomly selected and we find the probability at least 11 of them have graduated, that would be the probability that 11 or 12 have graduated. That means, since there's no duplication there, that would be the probability that 11 graduated plus the probability that 12 graduated. Okay, so let's do this. So the probability that 11 graduated, remember N is 12, so we would have 12 factorial over, this is X is 11, 11 factorial, and sorry for writing so small, 12 minus 11 factorial. P is 0.925 to the X, so to the 11. And then Q, which was 0.075 to the 12 minus 11, so to the 1. Okay, and then the second one will be 12 factorial with 12 chances of success, so over 12 factorial, and then 12 minus 12 factorial. 0.925 to the 12 power, that's our number of successes, and 0.075 to the 12 minus 12. So a couple of things to remember while you're calculating that. Anything to the 0 power is 1. And this is 0 factorial in this denominator, which 0 factorial equals 1 also. So when we plug all this in and calculate it, we're going to, and add those two probabilities together, we're going to get a probability of 0.7741 for the combined probabilities. Okay, next one. Let's switch colors to a nice dark green. If 12 of the students from the special programs are randomly selected, find the probability that exactly 9 of them graduated. This is actually easier than the last problem. The probability that exactly 9 graduated would be 12 factorial over 9 factorial times 12 minus 9 factorial, 0.925 to the 9 for number of successes, and 0.075 to the 12 minus 9. And plugging that in, that's all we need to do. Not like the last problem where we had to add. It's exactly 9. And when we plug this in and figure this out, we get 0.0460. Okay, without knowing things like standard deviations and finding how far away we are from the mean, usual and unusual is usual values is usually greater than 5%, and this is less than 5%. So a 0.0460 is smaller than 0.05, so this would be unusual. Okay, so we would have an unusual event. Okay, last one. If 12 of the students from the special programs are randomly selected, find the probability that at most 9 of them graduated. Now, let me scroll up a little bit here to give us some room. There's 2 ways to do an at most. So at most 9 graduated could be calculated doing, okay, well that could be none graduated plus the probability that 1 graduated plus the probability that 2 graduated, and and so on, up to the probability that 9 graduated. But we wouldn't want to include the probability that more than 9 graduated, so no 10 or 11 or 12. That's one way to do it. That's a lot of probability calculations. We could also do the complement. So we could do 1 minus the probability that at least, or I'm sorry, let me rephrase that. That's not correct. That more than 9 graduated. So in other words, 1 minus the probability that 10 graduated, 11 graduated, or 12 graduated. Okay. So furthermore, we could do each one of those probabilities independently, but you know what? We already did part A. And if you remember part A, if I scroll up, that was the probability that 11 graduated or 12 graduated. Those two are added together. P11 plus P12, we already know, is 0.7741. So let's use that. P11 plus P12, we already know is 0.7741. So I'm going to highlight it just so you can see where it comes from. I'll do this in blue. This, P11 plus P12, comes from the first one we did. So we can do all that work again, but we don't need to. The one thing we do need to figure out P10. So let me go over here and find the probability that 10 graduated. So that would be 12 were selected, so 12 factorial, over 10 successes, over 10 factorial, and then 12 minus 10 factorial. 0.925 to the 10th, and 0.075 to the 12 minus 10. I'm going to go through this calculation really quickly just to make sure you know how to do this. This would be 12 factorial over 10 factorial times 2 factorial, and then 0.925 to the 10th, and 0.075 to the second. There's a lot of cancellation that can happen when we have our factorials. So that 10 factorial in the bottom means 10 times 9 times 8 times 7 times 6 times 5, and 12 factorial in the top means 12 times 5 times 4 times 3, 12 times 11 times 10 times 9 times 8, so on down to 5, 4, 3, 2, 1. So that 12 factorial on the top and the 10 factorial in the bottom cancel quite a bit. And we've got 12 times 11 left over the 2 factorial. And this didn't get written in. 925 to the 10th and 0.075 squared. 925 to the 10th and 0.075 squared. When we plug that all in, so what I was saying a second ago, this factorial cancels entirely with the 10 factorial. Okay, when we do all these calculations for the 10, we get 0.1702. Okay, so our probability for this part is going to be 1 minus 0.1702 plus 0.7741. And when we calculate that, we're going to get a probability, bear with me for 1 second, of 0.056. I'm sorry, 0.0556. 0.0556. Okay. They'll ask us one more question. Would it be unusually random to select, would it be unusual to randomly select 12 students from a special programs and get at most 9 to graduate? Well, this number, 0.0556, that is greater than 0.05, so that would be not unusual.